Guys, I'm going to be talking through lesson 10.6 and how to find segment lengths in circles. First theorem that we're going to be looking at here is theorem 10.14. And this is when we've got two chords that intersect inside of a circle, right? So you see chord AB, you see chord DC there, and they intersect at point E. Now, if I'm looking at segment AE here, right? If I'm looking at segment AE there, that is a segment of a chord, right? So whenever we refer to parts of a chord, right? So like EC, EB, DE, those are called segments of the chord, right? And we're going to use segments of a chord to be able to find, missing parts or chord lengths or segments of chord lengths, that sort of thing. So if we have two chords that intersect inside of a circle, then we are able to conclude that the product of their chord segments are equal. So you'll notice here I've got AE times EB, right? AE times EB. That's going to be equal to DE times CE, or DE times EC. So this is just part times part is equal to the other part times the other part, right? And we can work through an actual problem by assigning some values to these chords, right? So let's say that this over here, this is X. Let's say this is X plus 2. EB we'll say is X plus 4. And then over here we'll say this is X plus 1, right? And let's say that we want to solve this for X. So what we'll do is we will take the parts, right, the segments of these chords and set up this product, okay? So I'm going to take AE, and I'm going to multiply that by EB. And I know that that is going to be equal to DE, which is X plus 1, times EC, which is X plus 2. Now, whenever we do our little multiplication here, we see that we actually end up with X squared plus 4X equaling, well, we got to do a bunch of distribution over here. That's X squared plus X plus 2X plus 2, which is X squared plus 3X plus 2. When you've got an X squared on both sides of your equation, you know that those go away. So this right here is going to be the part that a lot of you get stuck on. You're going to say, well, wait, there's an X squared there. These guys cancel because I've got the same thing on both sides of my equation. This right here is just 3X. And if I subtract that 3X from both sides, well, I'm left with X equaling 2, right? So we can set up a problem when we see it like this. When it deals with two chords that intersect, we can just multiply or find the product of the segments of both these chords and set them equal to each other, right? So there we get X equals 2. All right, our next little thing that we're going to be looking at here is some more vocabulary. So let's say I've got a circle, and I've got a couple of segments thrown on here. So this big blue one here, the big blue mark that I've made, represents that entire segment, both the red and the purple, right? That is called a secant segment. It's a segment that contains a chord of a circle and has exactly one endpoint outside the circle, right? It's got exactly one endpoint outside of the circle. We see the chord is purple. That's just a segment that goes from one side of a circle to another. And this external segment in red here, that is the external part of a secant segment. That is, it's basically just the secant segment that is outside of the circle. And then in blue here, we see this is a tangent segment. Tangent segments never go inside the circle, and we notice that the endpoints are outside. Right here, I've got one endpoint on the circle, and then I've got another endpoint outside the circle. Well, how are we going to be using this? Brings us to theorem 10.15. And this is when we have two secant segments. Okay, we have two secant segments that share a common endpoint. And there's that common endpoint right there. It's at E. Shares that common endpoint E. This one is kind of an easy one to mix up and mess up, because a lot of people, what they do when they set up this guy right here, when they set this up, they end up wanting to do EA times AB, when really what we do with this problem is we take the external segment and multiply it by the total segment, right? So I'm going to take EA and multiply that by EB, right? EA times EB. External times the total length just so happens to be equal to the external times the total of your other one, right? So I can take EC and multiply that by, this total segment here. Well, what does that look like in practice? Let's throw some values in here. Okay, let's say that AE is equal to 4 and BA is equal to 5. Then I know that CE here is equal to 3 and DC is X. And I want to solve for X. Let's say I want to solve for X. Well, let's use our product equality, right? The equality of these two products right here, and use theorem 10.15 to solve for this. So what I do is I need to take the external, AE, and multiply that by the total, which is 9, right? That's EB. I'm not going to take 4 times 5. I'm taking 4 times 9. And I set that equal to external, 3, times total. Well, total, that's 3 and X. I don't know what that adds up to, but I can just write 3 plus X, right? I'm taking 3 and X, and that's what gives me that total. So from here, all we got to do is solve. This is, I'll use a little distribution. I'll take 4 times 9. That gives me 36. I get 36 is equal to 9 plus 3x. That's just easy pre-algebra stuff right there. Subtract 9 from both sides. You're going to get 27 is equal to 3x. So what does x equal? Well, x has to be equal to 9. And we could utilize that, to find, well, that means that DC is equal to 9. That means that DE, that total secant segment there, has to be equal to 12, right? We can utilize that information to solve for others. All right, our next theorem is when we've got a tangent segment, we see that EA here, and a secant segment, ED, that they share a common endpoint. That endpoint is E. And theorem 10.16 says, well, whenever you've got a tangent segment that is sharing an endpoint with a secant segment, you can solve for individual parts of these segments by setting up this equation here, right? We can take that tangent segment and square it, and it will always be equal to the product of external times total. Well, let's do this again. Let's find some more values that we can plug in here, and let's solve. Okay, so let's use a little purple action here. Actually, let's go orange. We haven't used orange. So let's say that EA is 16. EC, let's label that as X. And CD, let's say that that is 8. Now, I know this is not to scale, but bear with me. So I've got EA, I've got EC, I've got ED here. And let's solve this for X. Let's solve for X. Okay, so utilizing theorem 10.16, let's set this up. So I'm going to take EA and square it. That's 16 squared. That is going to be equal to external times total. Remember, it's always external times total when you're dealing with secant segments. Well, 16 squared is 256. And that's going to leave me with x squared plus 8x. This is when things get a little tricky. Okay, and I'm going to switch up to black here. Because this x squared isn't going to cancel out with anything, right? We're kind of stuck with it. Well, how can I solve this then when I'm dealing with an x squared? This is when we need to utilize our quadratic formula. We need to write this out as a quadratic equation. Okay, so I'm going to subtract 256 over to this side, and that gives me x squared plus 8x minus 256 is equal to 0. This is a quadratic equation. Quadratic equation, which you guys have seen and dealt with before. You would have learned about these guys in algebra, and we've dealt with them a little bit in geometry, but not that much. And when you have a quadratic equation that is not necessarily factorable, what we need to do is utilize our quadratic formula. So for those of you who don't know, the quadratic formula, and I'm going to go, let's go purple for this guy. The quadratic formula is something that you are going to need to use quite a bit, especially when you get into Algebra 2, pre-calculus, etc., right? And it goes negative b plus or minus the square root of b squared minus 4ac divided by 2a. There's a little song that goes with it. I think it's negative b plus or minus the square root of b squared minus 4ac all over 2a. Thank you. I am actually thinking about trying out for American Idol. I don't know. It's maybe The Masked Singer. I don't know. It's just a little bit of a dream of mine, but whatever. What are A, B, and C, right? What are these values? Well, in a quadratic equation, the mother equation is ax squared plus bx plus c equals 0. Oh, so we just have to replace the values with what we know. Okay, so that means, and this, by the way, is what x is equal to. X is equal to that stuff. This means we get to write out x is negative b. Well, what's b? B is 8, right? It's right there. Negative 8 plus or minus the square root of 8 squared minus 4 times a is 1, times c, which is negative 256. All of this divided by 2a, and a in this case, again, is 1. Seems a little scary, but we're going to be just fine, right? We can utilize calculators for this stuff. It's really going to be all right. So what we end up with here is our negative 8 divided by 2. That's going to give us negative 4. Plus or minus, okay, well, looking here, let's see, square root of 64 minus 4 times negative 200, well, let's see, negative 4 times 256, that's going to give us 1,024. So that gives us 64 plus that. 64 plus that. Which is 1,088. So we've got the square root of 1,088. And that is also over 2, right? This 2 canceled out with 8 over here, but we also got to keep that 2 under there. 1,088 ends up, I think, reducing down to, I think it's like 8 root 17. So we've got negative 4 plus or minus. And, you know, we could just use our calculators and say, well, let's find the square root of 1,088. And it's about 32.98. So we got plus or minus 32.98 divided by 2, which is 16.49 roughly. Okay, so this right here is roughly this. Now, with the plus or minus, that means I need to add this and then subtract it. So whenever I add it, I get about 12.49. So negative 4 plus 16.49 is equal to 12.49. And when I subtract it, Let's see, negative 4 minus 16.49. That gives us negative 20.49. Now, here's the thing, though. Can x, can that be a negative value? No, because it represents a distance. So this right here can't be our answer. So we're stuck with 12.49 as our answer for x. Those are one of the more difficult problems, which you are probably going to come across maybe once or twice on a quiz or a test. But don't hesitate to reach out if you guys are still confused. There are plenty of videos out there that cover, using the quadratic formula and that sort of thing. But let me know if you have questions. I'm happy to help. You guys stay safe out there.